So I'm Batman, but to hide my identity, I work as junior software engineer at Betacraft. So I completed my graduation in 24 as mechanical engineering. So I am from Bihar and then moved to Varanasi for my 10th and 12th, and then to Gorakhpur for my graduation. Okay, and then I am residing in Pune. So yeah, my talk is GraphQL in Rails. So we have quick 5-minute live coding. So how to implement GraphQL in Rails. So first, why GraphQL? So there is a conventional API, which is the REST API. So they have endpoints with like get, post, put, delete. So the main the main part of the response of an API code in REST API are the status code, headers, and the request body. So what are their advantages and their disadvantages? So advantages are they are scalable, flexible, and independent. But disadvantages are overpatching and underpatching. Means there are fixed set of data. If we want more data than that set of data, then we have to modify in the code. And there is a versioning. Means like we have to maintain the proper version for each set of data. And then here comes GraphQL, which is developed by Facebook in 2015. So the main thing is that the main advantage of GraphQL is that what we need, we get from the API. Main difference between GraphQL and REST is GraphQL is a technology or language, but REST is an architecture pattern. Advantages, no overpatching, no underpatching, no versioning required. Disadvantages is it is complex and it provides status code 200 for every. Let's start. So these are the commands that I have already ran. Creating a Rails app, then creating a model, then running migration, then installing 2 gems, the gem GraphQL and GraphQL Rails in development to render in the browser. Then I run bundle install, and then I run the most powerful command, which is Rails generate GraphQL install, which will load these sets, in which we can see there is a schema.rb, base mutation.rb. We will now let's see how we will work with GraphQL. So first we are going to install the GraphQL object for users. I think I have less time left, so I have a backup. Just quick. Yeah. So what happen if we run? Sorry. Yeah. So in this, when we will run Rails as, you can see there is a GraphQL display where we can easily write the queries we want. Like for users, it is first name, last name, or email. If we run this, then we got all the data which are seeded in our database. And if I just remove email from here, then we will only got first name and last name without changing anything from the code. So if we also want, like there is, if there will be any, let me just go to code. And I can. So it is not here. So if we have any other references like has many movies, then we can also display movies here. And without any generating controller code to define the set of data, we can easily render by writing just movies here. So we do not have to do that much with the help of GraphQL. So yeah, that's about it.
So first of all, I am Akshay Birazdar. I am a senior software engineer at Mekari. And today I am going to tell you about how a small CSV just make our production server miserable, right? Okay. So how did it start, right? It started with an innocent, export, right? What did this export job did? It did nothing special. It generated a CSV, it uploaded it to active storage, right? Let's look at the code, right? It is just csv.generate. We are creating some attributes, pushing it to CSV, and attaching it to active storage, right? So the main method we need to look into it, csv.generate. That csv.generate, what it does it creates a CSV string and appends it to an object. Keep it in mind. It is the whole thing. So first thing for solving this kind of problem is to profile it. So we are going to use a simple profiler. That is just, what is it going to do is first get the memory before the program starts. And after the program is, my export job is done, we will capture the memory. So the difference between start and end is the memory usage, right? So what was it for my simple export job? It started with 125 MB, but it completed in 261. So 135 MB of usage. My CSV was generated around 100 MB, so I can say that it is consuming a lot. This is not desirable, right? And what happened with us? Why our server failed? Our Kubernetes pod was allocated 1 GB of memory. But once the Sidekick had like 500 MB allocated, it overspilled. We got OM, we got killed. That's why that title, right? So why is it bad? As we saw, the CSV.generate actually holds the string in the memory. It doesn't allow GC to collect it. So in the morning talk, we saw from Kushal that why is it bad, right? If you hold the memory, you are not able to free it. So can we improve it? Yes, we can, right? What is enter temp file? So what we can do, we will create a temp file. Temp file is nothing special, but a file object that is unlinked. So when we create a CSV, we will not create it in memory. We will create it with a temp file object. So as soon as our row is generated, we will push it into the file. We will not hold on to that attributes and not hold on to the memory for this. So now GC can come and just collect it, right? So talk is cheap. Let's see the benchmark, right? 18 MB, 135 MB versus 18 MB. It is a 7 times memory saver. That's how we saved our server. So this is a small part of bigger war story. If you want to know more, catch me outside. So that's me, Akshay Birazdar. I write sometimes blog. You can scan it. You can connect me on various platforms. So that's me. Thank you.
Hey, hi everyone. So I might fumble, so I'm just apologizing beforehand. So yeah, Hotwire in anger. That's the title of my talk. Who here knows about Hotwire? Couple of folks, nice. So my talk is just gonna be a little bit about how we use Hotwire at work. So yeah, I'll get started. So that's me, Animesh. I'm a Rubyist and I'm a meta programming connoisseur. Really liked Chaitali's talk and Vishwadheesh's talk, if you can tell. What are we building nowadays? I'm building trypage.io. It's fully built on Hotwire. Now, for those of you who are not familiar with Hotwire, what? Hotwire? So what is Hotwire? It's basically sending HTML over the wire instead of JSON. You don't need to write React or Vue or whatever. Just send HTML. Consists of turbo drive, turbo streams, and stimulus. And that's pretty much it. 1 second. So talk is cheap. Show me the code is what usually people say. And I'll just show a demo, very simple. So this is a form. It has a validation on top of it. I'll hit create. It re-renders the model. That was not React, by the way. That is just Turbo. The controller is very simple. It just says, hey, if it's valid, the usual Rails convention. But the next bit that I'll show is going to be pretty awesome. It's basically a form builder. It's going to be a pretty awesome demo. It's a form builder in Hotwire, if you can believe it. So, I don't know, RCI demo, if I can type. My server running. Nice. So, this is a form builder that our team built at Peach. It's nothing, you just keep adding fields, blah, blah, blah. And if you notice that or that auto scroll thing, that is stimulus, right? And it all ties together pretty neatly with Hotwire and turbo streams. And if I highlight it, that little green highlight is stimulus. So yeah, this is what we built, and it's actually this is actually a new thing in WhatsApp that we're building. So if anyone wants to try it out, I'll have a QR code somewhere. 1 second. So if anyone is interested, you can try this out, but if you're not comfortable with sharing the data, you may not do it, but I have a demo video. If folks are like interested, I can just show it. Oh yeah, one more bonus. So I wrote a very small DSL to drive these app backends. This is how it looks like. So basically it's like very domain specific language. And yeah, that's pretty much it. Thanks. If anyone wants to catch up with me, talk about Hotwire, how we're using it, and other Railsy things, you can catch me on LinkedIn and Twitter and roaming around in the hall. The middle adjective might be loitering, but yeah. So yeah, thanks.
Good evening, everyone. A bit introduction about myself. I, Smriti Gupta, joined Pattern last week as Principal Software Engineer. Prior to this, I was working with George Software, and I come with 9 years of experience in the IT industry. So my topic is code smarter, not harder in e-commerce. So how this is possible? By using the use of design patterns. So design patterns are those superheroes. They just don't wear caps because they wear good practices. So in this 5 minutes, I will quickly try to cover some design patterns that can be helpful in e-commerce with some real-world examples. So First is strategy pattern. So it's nothing like just we are up for the first date and definitely you want to come up with enough options to impress. So similarly, when you reach the checkout page, you are presented with so many options. You want to pay using PayPal, Google Pay, GPay, credit card, debit card. The interesting one is Afterpay, and the more interesting one, which does not exist, is buy now, pay never. So let's see. So these are the different strategies that exist. So strategy pattern in commerce is nothing about switching between different payment strategies. So this is just a snippet. On the right, you will see how you're switching between different strategies for different customers. You can have credit card or you can have PayPal. On the left, you can define different strategies. Next is observer pattern. So observer pattern is nothing but as soon as you must have observed, as soon as you add an item to the cart, you start getting email. It's like everyone is watching you. You open your WhatsApp, text messages, email. It's like, okay, limited stock on your added item. So, and limited stock on your added item. It's are you watching the shoes? It's just we are lucky that our family member is not getting that messages. Okay, your son and daughter has added that item in your cart. So how that is possible? That is the observer pattern. So quick example on the right, before placing an order or adding an item to a cart, you add observers around it and it send out those email notifications everywhere, wherever you're logged in. Next is factory method. So it's like a barista picking you whether you will get a regular coffee latte or you will get double shot espresso. Because if you're a customer, then regular coffee, it's their choice. And if you're an admin, then you will get the espresso. Similar, in this example, just replace the barista with your e-commerce site and your regular coffee with your access permissions on your dashboard. So it's like you're not, no questions asked. So you're hiding the details of the implementation. And if you see on the right side, you just pass the user, create user as an admin user or a customer user, and they will have different access roles. Next is singleton pattern. It's like your user gets only one card throughout the session, whether you are logged in on an iPhone, iPad, everywhere, whatever items you were added, you will see those same items anywhere at any time. So it's about one session, one card, across users. So you can see on the right side, as many items you add, it's just that your wish list keeps watching us that, okay, you have added me 3 months back. Decorator pattern, nothing but it's decorate your order as much as possible, because in the end you actually end up paying more than what was there. And how? It's like you have added an item, you want a warranty, you want a gift wrap, you want discounts. So it's just like decorating your item. So this is about decorator pattern. So in the right side, okay, there is an order with a gift wrap. On top of that, some discounts. So this is how decorator pattern works. Thank you.
Today, I'm going to just discuss about the silver bullet. A question might arise what this silver bullet might be. So from the morning, right, everyone is talking about how to reduce the memory or how to optimize the memory. So for reducing and for optimizing, what we all do, we first, like, we do the code profiling, we find out any opportunities in the code profiling, we optimize it. We do a infrastructure scaling, heap analysis and gem analysis. With all this stuff, we achieve it, right? We achieve the memory reduction and optimization. But as a human, right, we want more, like dil mange more. So what we did, we went one step ahead and we thought of like, what if we directly modify, or is there any opportunity to update the Ruby itself, the underlying Ruby itself? And this was our silver bullet. We identified one component called as memory allocator. Now this memory allocator, like, it is responsible for allocation and deallocation of the objects. But when it allocates and deallocates, right, in case of deallocation, there is an issue with the memory fragmentations. And when in case of multi-threading, right, like Ruby is also like internally it has a multi-thread also, even in single process. So it might over-allocate some of this memory. So to solve these two issues, so we thought to change the underlying memory allocator. So we identified few of the memory allocators. It's a malloc trim, TC malloc and JE malloc. So what we did is we did some round of executions on all these three, and we finalized the JE malloc as a final one. So with the JE malloc, we compiled the entire Ruby and our code base to the JE malloc, and its result, right? If you see at the results, so almost like 30% reduction in memory we have observed it. So this 30% reduction in memory has directly impacted the 30% of the cost. So there was a 30% reduction in the cost. Like at the Coupa, like the scale of the servers are almost like thousands. So it might go in the thousands of servers. So for all the thousands of servers, we optimized around 30% of the infrastructure cost. And also apart from that, we achieved a 13% improvement in the app boot up time. So for this, like with this 13% improvement, we also achieved much more performance gain to it. So this has all resulted in a very good improvisation to our entire application. So some of the key takeaways is that, like, opportunities to find the right opportunities, right? It's not always in the code or infrastructure. Sometimes it lies with the operating system or the programming language which we are working. So thank you.
Improvement, which is great, right? Then we implemented everything, did a rigorous performance testing, and the results were very similar to what we saw on the POC. So seems pretty simple and amazing, right? But is it really? Talking about the risk management. Sure, we had like all the test coverage, we had the QEs, but with the number of users that Coupa has, like we have thousands of customers, and in turn, they have thousands of users. With all the configuration that we have, it's virtually impossible to test every configuration possible. So what we did, we creatively used Scientist Gem. I'm not sure if everyone knows here, but what Scientist Gem does is, you can run the code parallelly, the existing code as well as the new code. So we integrated that with one of our internal tools. We ran it on the actual production data, and what it helped us, as you can see here, I'm not sure if it's visible, but it helped us capture like a couple of bugs. So if there is a mismatch, we used to push that in ELK, let's say, and if you see like the control value and the candidate value, control value is nothing but how your existing system is going to respond, and the candidate value is how your new changes are going to respond. And as you can see here, control value used to give 0 results, but with the candidate value, we saw the IDs being there, right? So basically what it means is, with the new change, user will be able to see the documents which they were not being seen earlier. and which is very like problematic, right? Because it's something users should not be able to see something that they are not allowed to see. So Scientist Gem helped us in that, and along with that, we went one step forward and had a staggered way of rollout. So what it helped us is to control the blast radius. So what we did, we had a configuration-based system where the new code will be applicable only if the configuration is enabled. So with that, we enabled it for like 1 or 2 customers. We gave a soaking period. And after that, once we had like more confidence, we did a mass rollout. And as you can see, the result, there was not even a single bug, which is a huge thing for a feature which is as critical, as complex as this account security module that I was talking about. So with that, I would like to wrap up my small talk. And if you have any questions around that, please feel free to reach out. I'll be happy to answer any questions if you have. So that's all from my side. Thank you.
So today I'm just covering one of the innovation, or you can say a framework which we have designed for, like after analyzing all the load, all the production issues, all those things. So this is like a new thing which we have introduced in our DB architecture. So yeah, so what we all do currently. So like currently we do like active. Like we have one DB node which is a master, another is also master. So the load distribution is not balanced. And the second flavor is like active and passive. Sorry, not passive. The DR node, which we majorly use when there is a disaster. So due to this, there is no scalability. There is no, like, we cannot utilize this database in a proper way. So we are just adding cost, and we are not utilizing them at their full capacity. So this is one of the okay. So what made us to like create this framework? So the first main reason was most of the read operations and as compared to the write operations. So if we analyze like the production load, we had a lot of read operations which were leading to the as compared to the write operations, and the write operations were served mostly by the master node. So due to this problem, the efficiency of usage of DB servers was not at the mark, and we were having more problems of scaling our transaction and our TPS to achieve those the TPS which we want to achieve. So these were the problem statement which we are facing. So for this, what we did is we created a service called as Vahana using the Makara gem on top of Makara gem. So Makara majorly helps us to basically do the normal like read and split of these operations. So, but there is no control over the what we can say like over the replication lag and over the slow. Yeah, so majorly like this service, what it does is it diverts all the read operations to the slave, and all the write operations are served by the master nodes. If this lag and the Vahana service, the main USP of this service is it checks the replication lag. If the lag is over the timeout, like the default Makara timeout settings, so it blacklists the servers, the slave servers, and again the read operations will be served by the master node. So due to this, like we have the flexibility to like divert our traffic to different slave nodes, and we can manage our different kinds of transactions to be served by different kind of slave nodes by just adding a slave node. So this enhancement helps us to create like more scalable product, and so this is one of the major thing which can help us to grow or to serve the production issues more capabilities. So this is flexibility to add in our multiple slave nodes. So this is one of the major thing which we have contributed in like in our current infrastructure. But yeah, that's all from my side. Thank you. If you guys are interested to get the configurations or to learn about more about this, you can catch up. We can catch up outside and we can discuss more about this. Thank you.
I hope, I think 90% of crowd here not have understood what the exactly topic is about. If you have understood the topic, I think you are in a good organization and you are doing good testing and you are releasing your product with a great quality. And if you are confused about this, let me explain it to you. So I think 99% of the people thinks that software testing is nothing but about finding the bugs, right? So it's no, okay? It's not at all like that, okay? No matter what all things you do, white box, black box, unit, integration, right? You are not doing it for finding the bugs, okay? If you are doing it only for finding the bugs, you are not doing testing, you are doing manual testing, which is not at all a software testing, okay? So, what we do at Coupa, okay? We do all these things, and I mean to say we means all the quality engineers. We don't call people in Coupa as a tester or a testing people, right? Or a manual testing team. No, we call them as a quality engineer, okay? So let me tell you what all things we do, right? Quality enabler, right? What we do is we always think about doing shift left approach, right? What shift left approach is, right? As a quality engineer, I am there since day zero of any feature we are releasing it in our product, right? So day zero means whenever there is a PM discuss or put their thoughts in front of dev that this is what our customer wanted to do, right? In that discussion, as a QE person, I am available for my team, right? And everyone in the team is available with respect to the features assigned to them, right? So we are there listening to what exactly PM wants it, right? When the technical design happens, we work with dev, we explain them the test scenarios that we are thinking of. Also, we work with PM to understand how customer is going to use that feature, right? Once it is released. And we think through all the business use cases which we have already released to the customer beforehand, and we make sure that there are no regression bugs because of this new feature, right? Beforehand, we thought through this, and we have the test scenario section in our design documentation, which we have to fulfill, right? That's what we do from day zero, right? Then quality peer, right? Quality peer is what? We have to work together, right? So, as a quality peer, what we have is, we have the automation test strategy planned where we work with PM, Dev, QE. Again, we will write our test scenarios, share it with Dev and PM, okay, and ask them to go through it. If we have missed something, let us know, okay? If we have not missed something, right, we will map all those scenarios with the acceptance criteria of the stories, right? So acceptance criteria is, which is nothing but a feature development, right? And then at the end, we will make sure that each test scenario has a automation coverage either in controller, unit, feature test, or an end-to-end test, right? We mark them, and we always make sure as a quality engineer that if out of 10, 5 scenarios are marked as controller test, are those literally covered by a dev in their PR or not, right? So that now it means that all the quality engineers at Coupa knows how to read the code, right? Because they are writing the code as well. Then test automation I just talked about. I'll just briefly talk about quality assurance. Everybody knows it depends upon the organization, it depends upon the product, it depends upon what assurance you want from your product, right? So it is industry based, so I'll not talk about quality assurance. SRE and DevOps, right? You might think of what SRE and DevOps role quality engineer might have, right? So what we do is, we make sure all our automation is there CI/CD, everything is tightly coupled with the dev code. So whatever the new dev code returns, our automation runs on that, right? And basically, yes, and basically it finds out the bug before that. And also we have one smart feature is big, where depending on where the code changes, we will run only those tests. So we have more than 30,000 tests, but we will not run each 30,000 on each and every PR, right? For the time saving. That is also we do. We can catch up outside for more details. Thank you.
I'm going to talk about this hack that I just did. I was working on this for the past 2 days and on the flight to this conference. And so I have a story about how this started. So I did this recent project where I wanted to analyze place names of Kerala. So a place name will have a cultural reason, a geographical reason why a place name is the way it is. That's a human evolution thing. So I want to do an analysis on the place names of Kerala. So I did this in a hackathon where I collected data from OpenStreetMap, and I used to populate data with an SQLite DB, and I did this on Wasm. So this is a web page, and I can type in a name, let's say an SQL query. What are all the places which ends with the suffix of Mughal? And when I execute it, I can get the data points here, which has that specific place name. So I can modify this SQL query as I want, and I can directly get the output here. And this is being used by SQLite and Wasm. Now, I want to make it more fancy because the Ruby active record is pretty good in handling database objects, and then you can do manipulations on top of that. So I wanted to do a bit more advanced, make it more flexible, and I wanted to do it with active record and the Ruby juiciness of doing things. Now, my idea was to have maybe active record. The SQLite works on the browser, so I wanted to see whether active record will also work on the browser. Now, because I have a full-time job, I don't much get time to do on those silly, hacky things. So I now do this thing called CDD, conference-driven development, where I will pick a conference, I will try to have this particular talk or something, and this idea, and I will work during the conference while the talks are happening, switching between listening to the talk and doing the thing, and I want to do this. So I want to do this idea on top of. So I tweeted about this. Oh, I can't get my Firefox. Oh, better. Okay, thank goodness. So I tweeted this out that I'm doing this active record thing, and the person who works on Rails and SQLite, told me that, so this tweet was there, if I got this working, I will do a lightning talk. That was my goal actually. So as I was doing this idea, I wanted to be the first person to get active record working on the browser. That's what my ideal goal was. And then Stephen tells me that this is already being done by Vladimir. Vladimir works at Evil Martians, and he is already working on this thing called Rails on Wasm. So basically, you can run a Rails application entirely on the browser itself, and this is very amazing, I would say, what's being happening here. So I looked into the source code, and I can already see that active record is already being used with SQLite on the browser. Now I just wanted that part, so I extracted that part out, and now this thing actually works. So on top of hacks, I made this. So my concept of doing, or idea of doing this was to, SQLite already had a Wasm plugin, or already had a Wasm thing. So what if we go, an active record uses SQLite extension to call SQLite query, directly execute the query. What if we go to the source code and basically change the call from SQLite to the Wasm calls? So that's what I wanted to do, and thanks to, there were like 2 meta-programming related queries in this conference itself. So that is the beauty of Ruby. I can override the function require and the gem itself. So when Rails or the active record tries to load the gem, I will override it. Don't load SQLite. I will actually make a custom SQLite Wasm adapter. And that was also being extracted from Rails source code. I modified that to get the JavaScript call here. So you can see the JavaScript call is being done here. And this is superbly hacky, very terrible code, but this thing works. And this will call the SQLite query from JavaScript, it will get the results, and active record can do it. And yes, what else? Yeah, and that's the thing, with great power comes great responsibility, and this, since Ruby allows you to do all kind of these hacky things, this actually works. Now I can show a demo here, 5124, what? 5174, okay. 49 seconds. So this is how the demo looks like at the moment. I can load a DB, cats, and you can see, okay, I should browse the console. Yeah, so cats.db is here. I can click on run, and you can see you can directly get Ruby errors on browser console now. Pretty great, right? And
30 seconds.
Now, okay, now I can. I'm going to change the table to cats and get a count. Run. There we go. 2 rows in the item, and I can also get place.all.plug, my typing skills, name, there you go, run, and I can get the 2 items in the record. So that's the demo. Thank you.
It's a very simple task, right? Because we know in Rails how email it really works. It's a very simple in the Rails because Rails provide us with action mailer where we can able to just create some methods and put some code on html.erb. We can able to see the email. It's a very simple. I'll just quickly show that, this will be that code. So we just want to have one mailer with a method, some blah, blah, blah operations over there. And at last we are going to call the mail method. It's a very, very simple. But if it's come to redesign, we need to have a good dev testing over there, right? Whatever designs that designer provided. If it's need to be 2 pixel, it should be in the 2 pixel. If it's need to be placed in the right corner top, it should be there, or else QEs will raise the bug. So each and every time if I do, I need to view the email, right? How we can able to view the email? We need to call this mailer in the console. If we call this mailer in the console, then we can able to get the email in the local host, and from that we can able to open that. For one time it is okay, very simple. Let's say our email has 4 to 5 components and you are building component each and every time. Then what we should do? Each and every time we want to, put the code, go, just trigger an email, see the UI. This should be get repeated. At some time, what will happen? There can be some small issue. So you'll notice that one issue, one point, you make the code change, trigger the email. Until you completely get satisfied, each and every time you need to go to console, you need to trigger an email. So this is some, it's some hectic process, right? But Action Mailer provides a previewing option for us, which means that html.erb, whatever we are writing, that can be directly previewed in the live manner. We don't want to trigger the email each and every time to view this. How we can do this? That's very simple. So what we want to do is we want to create one preview. So this should be the file format, and where it should be get created. It should be get created in the test folder. So just go to the test folder, have the mailers, create the mailers, create the previews. Inside that we can create some preview files, and this preview file should be get invoked with the action mailer preview and have some methods. Inside the method you want to call your mailer. So already we have one mailer. Inside this we just want to create a mailer. And Rails has this special URL that is Rails/mailer. If we just, after setting all these things, if we just directly, trigger this URL, we can able to see a page like this. So we can able to see a page like this. Here we can able to see all the methods we have created. So here I have created only one thing, right? Notify counter. If you want some other methods, you can just simply add on. And here we can able to see remaining all things over there. And if you want to see a particular thing in live, you just want to click on this notify counter like this, a UI will be get open and we can able to see the live. If you want to make any changes over there, just go to the html.erb file and just make the changes and see in the live UI. So this is about the action mailer preview, and its configuration is also very, very simple. And also here the one other special thing is it has the path configuration as well. I told you, right, inside the test folder, go and create the preview mailers. It is default path configuration. If you want to customize that, we can customize that. Just use this config action mailer preview path and set whatever path you wanted. There we can able to see that. So this is the about action mailer. To have more detail on this, this will be get published in our Rentley engineering blog. So you can just go and check out in this. And adding to that, we'll be having we'll be having some other stacks blocks as well in our Rentley engineering blog. So if you want to just go and check it out, please do that. Yeah. So thanks for your time.
Generally, we have heard people do that stuff in Python and JavaScript. But Ruby has an interesting library called LangChain, which I have used to create a small POC. Let's go through that first. So I have something to show. Yeah, I'll continue on this. Okay. So first, let's see what's on production. So how does a chatbot look like? So we have this knowledge base that we have created, and we can actually ask English natural language questions, and it will answer with the knowledge that it has on this documentation website. And you can see it works. So how to create this locally? So it's just a simple code. We are using a library called LangChain, as I said. What we do with that is basically we use a technique called RAG, which is retrieval augmented generation. We pass the specific knowledge that we need about our website as documents to the prompt, and basically it uses that documents to summarize and provide us with the knowledge specific answers, because other than that, LLM just have like the general purpose knowledge like English, math, science, but nothing specific to the use case. So what I've done over here is actually got a JSON of the speakers for today's Ruby conference, and I've uploaded the documents to my vector database in Postgres, and we can actually ask different type of questions and it will answer us based on that. So let's try that. Let me copy this, and I'll open a bigger terminal. So it has like a speaker JSON, you can see. It has the name, bio, and talk title and description. It takes a while for it to run because it's querying OpenAI. Okay, so it answered, yes, there is a meta-programming talk, and it also said it's by Chaitali. So you can create this bot using this LangChain RBGem. There are some limitations, however. For example, actually you can combine multiple documents together also. If I ask who are the speakers from Coupa, there are 2 speakers from Coupa, so it will actually combine both the documents and summarize it for us. Okay, so Sumit Day and Puneet Kushwani, it answered it correctly, but this technique is used when we query the documents. So there is a limit to how much document or context we can add. So right now the default value is 4. So if I ask the chatbot something like this, how many talks are going to be there? It will actually give us the wrong answer because it will only fetch the top 4 matching records. Takes a while. So you can see there are 4 talks, but actually there are 12 in the database. And it also cannot answer something that is not there in the context. So I'm not a full speaker, so it does not know that what I'm speaking about. Oops, I copied just the question. But yeah, you get the idea. It will say no context found. So let's see the source code actually. It's pretty simple. The gem file has only 2 gems actually. It's LangChain RB and Ruby OpenAI. The other 3 are dependencies, and of course Postgres database. It has an extension called PG Vector, which enables us to add vector embeddings, which is just text converted into numbers for easier querying. And this is the file where I have actually used the LangChain gem object. So we create an LLM object, then we create a client for the LLM, and then we call 2 methods, similarity search, which will query the documents for us and get the context, and then chat will pass that context to the chat, which is very similar to the OpenAI chat completions API that we use, and then I'm just printing it out. So yeah, that's it for me. I'll just let you know the speaker list. I have some context, that's why I got it. I'm just joking. So I actually asked ChatGPT only. I pasted the source code into the ChatGPT and I got the JSON from it. So yeah, thank you. AI is amazing.
Associate software engineer at G2. Let's wait for the, okay. Yep. So I'm here to talk about documentation, which I think is perfect for this time. All of us are very excited and energetic, and documentation is something that, sorry? Yeah. And documentation is something that makes us all, very excited and active and not sleepy at all. So the point that I'm trying to make is that documentation can actually be a superpower if you use it right. So how do I structure this, right? The way I thought of structuring it is through 3 questions: the what, the why, and the how. So let's start with the what. So this is the definition that comes up if you Google what documentation is in programming. And I think all of us here know what documentation is, probably better than I do. So the perspective that I want to bring here is this. All of us think that this is documentation, a very well articulated, formal document with design diagrams, architectural patterns, and all of that stuff. But this also is documentation. Just a couple of lines of explanation of the thought process that you had while building something. It could be informal, it could be ugly, it could be just random words mushed together to form a sentence that you understand. And this is still documentation. And the point that I'm pretty much trying to make is that level 100 is what all of us think when we hear the word documentation. But it doesn't have to be that. It can even be level 0, which is something where you understand it and you can use it as a reference for future, where you come across similar problems, or someone in your team comes across a similar problem and you can help with that. So we can all start at level 0 with the aim of reaching level 100 at some point. So now let's go to the why. And I think this is something that is very relatable to all of us. Who wants good documentation? All of us want good documentation. Me personally, I graduated recently, and coming in, everything is new and everything is so complicated. And how do I learn about this? I would like to have some documentation. But at the same time, if you ask a question as to who wants to write good documentation, there are very few people who want to do that. And I personally am an obsessive note taker. I make notes of everything. Even today, I had made a lot of notes. You can reach out to me in case you need that. But I personally think that for me, the documents that I write, which might not follow any structure, which are very much my own thing where I am doing something for my benefit in the future because I don't trust my brain to keep track of everything, I use it as a secondary memory, basically. And that is something I feel is an not unknown, but an untouched aspect of the power of documentation. And moving forward to, okay. So how do we take documentation, right? You could start simply with just your note-taking app. You can write a couple of lines, let's say some common debugging techniques, something that you want to execute in the terminal, some commands that you might not remember because you don't use it regularly, and things like that. And what I personally use is Obsidian. Any Obsidian users in the audience? Yes, Markdown is amazing because it gives you a basic amount of formatting, in my opinion, and at the same time keeps my obsessive nature in check, where I don't obsessively, use colors and all of that. But yeah, that's a different story altogether. And I think Confluence is what a lot of people use for official documentation. So you can start wherever you want, but any kind of documentation is good documentation, is basically the point I was trying to make. And yeah, I hope that was insightful, a little bit at least. Thank you.
Okay, so what is gRPC? So first of all, gRPC is a remote procedure call. This framework is developed by Google, and this is the open source framework actually. It uses HTTP2 for transport and protocol buffer as an interface definition language. Then, gRPC is well suited for the communication between the microservices. It's efficient, it's easy to use with the minimum overhead. So that's about the gRPC. So we see why gRPC, what is its advantage? So the major advantage of gRPC is it is really good suit for the faster communication between the microservices. Then we can look at the gRPC as an alternative to REST APIs. So usually we communicate between the microservices using APIs. So we can look at the gRPC as an alternative to the microservices. It's faster because it's used the HTTP2 protocol at the transport layer, which is designed as to be a faster and more efficient. And it also supports the multiplexing and header compressions. Then the vital part of the gRPC is the proto buffers, or we can call it as the protocol buffers. So protocol buffer is the vital entity, and it is actually a structure of the messages that is used for the communication between the microservices. And proto buffer is actually serialization, is used in serialization format, and that's why it is the faster than JSON. Like in our API we use the JSON, so it's the faster than JSON because of the serialization, deserialization. It's easier. And one more important point of the gRPC is it supports the multiple languages. If our microservices are built in different languages, so it's really good to interact with each language, and it interprets the language very quickly and very fastly with help of the protocol buffer. So next here is I would like to show how does it work with Ruby. So it's really simple. First, there is a gem install, gRPC. Then the second one is, it's important one, it's a proto file. So proto file is nothing but it's a gRPC format, and it is consist of the message body and the method. Like here, say hello is my method, and hello request is my request body, and hello reply is response body. And this is the language, this is the interface definition language. So whenever I run the command, that third one, third pointer, so it generates the corresponding Ruby code for this proto. And here is my client and server to communicate with it. So here that say hello method that denotes the say hello from the proto buffer file. And here is my client. Here I have stubbed the server, and by stubbing the server, I connect it to server and I call the say hello method. So yeah, this all about the coding. So I have a small demo to show all of you. So yeah, this is the so here is my proto buffer file, and its respective Ruby code is here. Hello world. So here you can see that hello request and hello reply. This is get transmitted into the specific Ruby code. And here in service file, there is a server over here. Yeah. And yeah, here is a short demo. Here is a server that is running, and here is my client. So when I call to my server, so it's sending the greeting message, and you can see on the server message has been sent. So this is the client server communication. So here I shortly show how does it work. So yeah, that's all. Thank you everyone.
So in today's online world, everything is online, right? May it be your financial details, may it be your medical details or your business, everything is online. So if everything is online, obviously it's vulnerable to security threats, right? So here are a few security threats that can attack your websites, starting from cross-site scripting, cross-site request forgery, and all of the others that you can see on your screen. So let's dig into them. So how do these attacks happen and what are they? Is something we'll be looking into right now. Starting with cross-site scripting, that is XSS attacks in short. So what happens here is when the attacker uses malicious scripts and they attack, they add this into your website, and these scripts are visible to other users. This is called XSS attacks, and there are 3 types of them, right? First is stored XSS. That is when these scripts are stored into your servers or your database, and then that is visible to other users of your website. Second type is reflected XSS. That is when these malicious scripts, they run, and all of the end result of these scripts are shown to your users. The third type is the DOM-based XSS. That is, these XSS attacks are directly shown on the DOM. It directly affects your DOM, right? So how do you prevent these XSS attacks in Rails? So here are 3 techniques. You can see them on the right side. That is, you can use edge context, you can use sanitize method, and you can use validations for your input fields. Moving on to the next, it's cross-site request forgery. I think most of you have already seen this. So in this attack, what actually happens is the attacker crafts a malicious link, and then the victim is sent this, and like when the victim clicks on this link, the attack happens, right? So it's very similar to phishing. The very simple example is when you get some strange emails on your Gmail account or something like that, very similar to that. So how do you protect against such attacks? You have 3 options here again, using this protect from forgery method, using CSRF meta tags, or you can just include CSRF tokens into your Rails applications, and that will help you prevent from these attacks. So next is insecure direct object references. So in any database that you work with, right, you have your primary key, foreign key, and all of these different keys that directly help you index different objects in your database. So in a lot of websites, what happens is these keys are directly shown as IDs. So this causes a lot of these kind of attacks. So how do you prevent such attacks? So you can use, you can enforce authorization, like you can use Pandit and CanCanGem for this, right? Next is you can just directly avoid guessable identifiers, right? Don't show your ID 1 or 2 or whatever. Then you can also use scoped queries for this. Next is SQL injection. What happens is SQL injection is in your input forms, if the user directly enters SQL code, right? These kind of attacks happen. So how do you prevent this? To prevent this, you can use ORMs, you can use database security, or directly you can use this active record-based sanitize method. Next is mass assignment vulnerabilities. How many of you have actually used mass assignment? Like, you directly use params and all of those values are actually stored directly into your table. Have you gone through these problems? Okay, so Rails actually supports this. You can just, if you want to just update one particular field, and if your user sends multiple key value pairs, then if you directly use params, then what happens is all of these fields can be updated, which is not what you really want. So here what you can do is you can use strong params, or you can use ATTR accessors to prevent such issues. And we have these authentication and session hijack as well. So authentication is basically you can use device, and for session hijack, you can use shorter session times, and you can also use MFA for this. So there are different gems you can use, such as rack attack, you can use secure headers, and brakeman also, that can actually help you prevent such attacks. So thank you so much. Here are some point of contact for me. Thank you so much for your time.
Okay, great. Hello, everyone. Hope you had a good break, good lunch and break as well. Okay, maybe let's start with a couple of questions. So I'll just wake you up a little bit. How many of you know NPCI? Not by just name, but what NPCI does. Okay, everyone knows. Okay, great. How many of you think it's a government organization? Okay. All right. And anyone knows how many payments we process every month or a day? Any rough figure, approximate number? 10 billion? What is that? All of them. Yes. That's a good answer, actually. All right, so okay, let me give you a disclaimer as well. I'm not here to sell you NPCI. NPCI speak itself for themselves, and I'm here to tell you a story of NPCI, right? And what we do, right? All right, so I'll quickly start with some stats around it. So if you look at a top Google top search engine in world, right? Currently, it gets around 100K request or API request every second, right? This is global number, okay, across the globe. This is what we get just on UPI in India, right? It's 120K per second, right? This is the digital payment volume per month across top 4 countries in India, right? And this is the number we get. This is what 16 billion plus now we are processing per month, right? So look at the scale that sort of we are approaching, and this is sort of just to give you a context or a perspective. And this is not just a technological marvel, right? This is now the new global benchmark that we are setting in the world. And UPI is now the global system, the largest global payment systems, which is processing 16 billion transactions every month. And this is just a start, right? So essentially we process 500 million, that translates to 500 million transactions per day. And we are ready for 1 billion transactions per day, right? And that we are approaching very, very fast, right? So for UPI, we believe it's just a journey that is getting started, right? But the roots of this transformation really stretch back 16 years back when we launched NFS. NFS is essentially a ATM network switch. So whenever you do ATM transaction, this switch comes in. So we started there, and you can see from then to now, we have been on a digital innovation journey, building new payments platform every year, every decade, and moving in a very staggering scale, right? Building it in a very staggering scale. So be it your salary accounts that you get credited, right? Be it EMI payments, be it your credit card payments, your farmers get subsidy today. All those payments, 99.9% payment today happens and goes through NPCI, right? So that's the scale that we are operating, and we are scaling very, very rapidly, right? And this is not possible by just building systems, right? This is possible because of a cutting-edge innovation technology, because there is no template available in the world to take and implement. We have to solve some of the complex problems in-house by our own engineers, right? And sort of achieve this scale. Plus, while we are building for billions, we are very open source at heart, right? We are using extensive use of various open source technologies. We are a big consumer of those technologies. And Go is one of the technologies that we have been using for all our new innovation projects, and we are building the totally new stack from scratch on Go, and that's why we are here as well. So this is one of the attempt to give it back to the community. While we want to consume, we also want to contribute. So while we have also started open sourcing some of the work that we have been doing, we also want to facilitate such kind of platform and bring talented minds together and grow the community around open source. So this is our bit of work from our side. So this is what happens through just open source now, right? I'm not going to keep throwing you numbers, but these are some of the amazing work that we have been doing just because of open source, right? So you will ask, Hrishikesh, okay, this is what you have achieved. Are you done? So my answer is no, right? So we are just getting started now, and we have a very long way to go. So the way we saw the evolution in the payment space, we see that will happen across all the asset classes across the world, right? Today, you are only talking about money aspect of it, right? But there are various other asset classes out there, a lot of financial, non-financial assets. You would have to have a similar UPI-like experience, right? How can you get that? So just want to give you a quick brief. So we were living in a very physical world. That's when you saw a lot of bank branches coming up. You have to go to bank, you have to visit, do your transactions. This is what the first form of money that we saw, or even the assets as well. Then we moved to the electronic form. That's where we started building ATM networks, right? So you saw a lot of ATMs coming up. You could go, you don't need to go to branch, but you can just go to nearby ATM and withdraw the money. Then we built IMPS. We built a lot of other payment systems, FASTag, UPI, right? So all these payment systems are built for electronic form of the payments, right? Now world is moving toward a tokenized form, right? Tokenized form is essentially tokenizing the assets, making it more programmable, more accessible, having a more control over those assets, as well as achieving instant settlement. So there are enormous benefit of moving to the tokenized world, and the entire world is sort of moving towards that. But then can we use our existing networks? Can we use existing technologies to achieve this? So our answer is no. We can't use existing networks that are out already, or existing infrastructure that is already been built. We have to build totally new infrastructure. We have to reimagine the whole networks, how they work. And this is where we are looking at building new digital public infrastructures and protocols and technology underlying it to the next level. So this is what we have been up to now. So we have been building asset tokenization protocol, which is very similar to UPI, but it is asset agnostic, right? It doesn't need to be payment, but it can be bonds, it can be gold, it can be various other asset classes that are out there. We are building a mobile application stack, distributed systems. How many of you use a digital rupee app here? Have you heard about it? That's an NPCI team. Come on, guys. You use? Okay. So yeah, it's a very initial days of it, but that is one first example of the tokenization of money, and that's a network that is live in India, right? One of its kind. It is probably one of the very few countries that have built this network. And I'll basically invite you all to experiment that, use it. Most of the top banks are offering that. So that's just a start, right? We have a long way to go, and tap into this ecosystem and build next-gen innovation on top of it, right? So we are looking at infrastructure, observability. Obviously, we are looking at AI, like everyone, right? Data science is another stack. So we are essentially building this playground to build national-scale, large-scale systems, which are sort of acting as a template for the world, right? And this is also an approach as India has taken, right? We are building now not just one or two products or systems, right? We are building the infrastructure, market infrastructure, the digital public infrastructure, we call it, right? So it started with Aadhaar, UPI, CoWIN, name it, right? Now the world is sort of following India. And obviously we want to use all the deep tech, next-gen technologies, to power these all platforms and make it cost-effective for the citizens, for the use, right? And then not just build for one particular entity. For example, we don't build it just for NPCI, right? We build it for the ecosystem to innovate, right? There are a lot of other startups come and build on this stack. So we build a foundation layer, but the innovators, startups, entrepreneurs can come and build their own applications, right? Build businesses on top of it. So that's what I think we are now reimagining our workforce as well. We have been looking at top-notch engineers. We are looking at architects, data scientists, AI leaders. I invite you to join this mission. We are on a journey, very, very exciting journey. So looking forward to also connect with you all. Thank you.